Hi everyone. So if you're here, you're probably having a Geometry Regents on Tuesday, June 23rd at about 1:15 p.m. or 1:45. I can't remember off the top of my head. So I'm going to go over a few documents that I have given my own students in geometry class to help prepare them for their Regents test. So if we notice, if we look at this problem, we have a flagpole that casts on the ground 91 feet long with a 30 or a 53 degree angle of elevation from the end of the shadow to the top of the flagpole. We need to determine and state to the nearest tenth of a foot the height of the flagpole. This is a 2-point question, so you can get points just for writing the correct trig function, even if your work is wrong or you don't write anything else. If you have the correct answer, you can get a point with no other work shown. I will say if you make more than 2 or more errors, you will not receive any credits. You need to be very careful. For questions like these, especially on the Geometry Regents, I do believe it's helpful to just have a diagram. So we're going to draw ourselves a right triangle. We know that this is going to be a trig problem because we're given an angle measure. And we're also asked to find the height. So typically when we see a question like this, we automatically know we need to use aka SOHCAHTOA. So let's start by drawing our flagpole. So let's say this is our pole here. And then we have our flag. Pretty flag. Okay, so if we look, we need to find the height of the flagpole. Since we're finding the height of it, we know that this side is going to be labeled as H because it's automatically going to be our height. The flagpole casts a shadow on the ground that's 91 feet long. On the ground being the key part. On the ground is going to be the bottom of our triangle because that's where the ground is. So 91 feet. And then we have a 53 degree angle of elevation from the end of the shadow to the top of the pole. The only angle that is at the end of the shadow and points towards the top would be this angle over here, in case you didn't understand elevation. And this one we're going to label as 53 degrees. From here, it's helpful to write out our acronym SOHCAHTOA. SOHCAHTOA. So we can determine which trig ratio we need to use. So let's label our parts. So if we can find our reference angle, which is 53 degrees, and create a straight arrow from it to one of the sides of our triangle, that is always going to tell us the opposite side. Similar to, if we can create a straight arrow from the 90 degree angle, that will always tell us our hypotenuse. In this case, the hypotenuse isn't labeled, which means we don't need it. And the only other side that we have left is the adjacent. The adjacent will always create like a curved angle. Since we're working with opposite and the adjacent, we automatically know that we're going to need TOA. Ew, I didn't realize I wrote that wrong. So we're going to do tan, which is going to be opposite over adjacent, and I'll clean that up for you all. So to write out our trig functions, we always start with our term, so tan, sine, or cosine, and then our reference angle, so 53 degrees equals our opposite side, which is H, and then our adjacent side, which is 91 feet. To solve for this one, we want to isolate H, so we're going to multiply both sides by 91. That way we can get the 91 out of the denominator. Once we do that, our new equation will be 91 times tan of 53 degrees equals H. Since H is by itself, all we have to do now is type this into our calculator. So we're going to go over into our TI-84. On your Regents, your calculator will be reset. So the first thing we want to do every single time you get your calculator is click mode. And we want to make sure it's in degree mode. So go down towards radian, click over to degree. I'm just going to hit enter, and then you can clear it out. Once we have that done, all we have to do is type in our trig function. So we're going to do 91 tan of 53. So 91, oops, and then tan, and then type in 53. That's all you need to type in, and we get 120.76. And that is approximately the height. But this question is telling us to round to the nearest tenth of a foot. So to round to the nearest tenth, we need to identify what number is in 10th place, which is the first digit to the right of our decimal place. So our 7 is in the 10th place, we're going to look next door to it. And if this number is 5 or greater, we're going to take that 7 and round it up 1 notch. If it's 4 or below, that 7 is going to stay the same. Then anything that comes after the 7, we just drop those numbers. So since it is a 6, that means we're going to round that 7 up to an 8. So our final answer is going to be 120.8. And that will be the approximate height of the flagpole. I do suggest boxing your answers at the end or circling them just so that the scorer knows what your final answer is. It's a lot easier to notice, but also just making sure your work is neat and organized as you're working through. Next up, we have this question from the June of 25 Regents. If you have been studying Regents questions, you may have seen this. But we have a park ranger who needs to secure 2 different trees with wire. So we see our wire, which is located over here. So we have that wire, and we have this wire. It needs to be attached from a stake to the ground in each tree. So we have our stake to the ground, stake to the ground. The wire is attached to 2 different heights and 2 different angles of elevation. As indicated in the model below, the park ranger only has 20 feet of wire. So we need to determine if he has enough wire to secure both of his trees. So in order to do that, we need to figure out the labeling of each side. So we have our reference angle, which is 24 degrees. We're going to create our straight angle off of it. And we know that that means it's going to be the opposite side. If we're able to create a straight line based off of the 90-degree angle, that side would be our hypotenuse. Same thing here. Straight angle off of the 90 degree. The wire is our hypotenuse. And then if we're using our reference angle, so 11.6, the 3 feet is going to be the opposite side. So let's write out our acronym. So, TOA. Since we're using opposite and hypotenuse, because the adjacent side isn't given to us, we're going to use sine for both of these. So to set up our trig function, always going to do sine, cosine, or tangent of our reference angle. So in this case, sine of 24 equals the opposite, so 4 feet, over, I'm going to put W for wire. For this question, we will need 2 trig functions though, because we're given 2 right triangles. So we're also going to need one for the 11.6 one. So we're going to do sine of 11.6 equals our opposite side, so 3 over W. To solve problems like these, I like to solve algebraically. For some of you, your strong suit will be multiplying by the reciprocal. Some of you will probably cross multiply. I like to multiply both sides by the denominator. It's a simple step that gets repeated over and over, but you always have to make sure that you're only multiplying by the denominator. Never multiply by the numerator if you're doing it this way. So when we do this, we're left with W times sine of 24 equals 4. If you notice, W isn't by itself yet. Since we're doing W times the sine of 24, in order to move that 24 or sine of 24, we're going to have to do the inverse multiplication. So we're going to divide both sides by sine of 24 to keep it equivalent. And that way, the sine of 24's cancel out. And our new equation now would be W equals 4 over sine of 24 degrees. We're going to do the same thing on the other side and then come back to this so we can plug it all into the calculator. So we're going to multiply both sides by W. That way these W's cancel out. And then from here, rewrite our equation. So W times sine of 11.6 equals 3. From here, we need to divide both sides by sine of 6 since it's being multiplied by W in order to isolate W. And then those two cancel, and we're left with W equals 3 divided by sine of 11.6. From here, we're just going to plug this into the calculator. So 4 sine of 24. Let's see if mine reset. Yep, so I'm just going to put it back into degree mode. This is also a free online TI-84, so if you don't have one at home, you can always use the one online. So as we stated before, we have 4 divided by sine of 24. And then we're just going to hit enter, and then that will give us our answer for that. Next, we need to do 3 divided by sine of 11.6. Oops. And then we get this value. When we have these two values, we want to make sure you write them down just so the score sees our work. I'm going to round them, but typically I would tell you to steer away from rounding. So we have 9.83 and 14.91. So since it's asking if we have enough wire, we need to see what the total amount of wire is that we have. So we have these two values, and if we're saying the total, that means we need to add them. But I'm going to add with the full value that we have rather than the rounded value. So I'm just going to highlight over our original answer for 4 sine of 24 and then hit enter, and it's going to copy and paste it for us. Plus sign, go back to the 14 one, hit enter, it'll copy and paste that. So now we get the full answer before we round, which is going to be a little bit different from the answer that we will have if we rounded. So we have 24.75. So the wire he needs is approximately 24.75. Well, approximately. But he only has 20 feet, which means that our answer would be no, he doesn't have enough. So we just write out no, the ranger doesn't have enough. You could leave it there, but if you want to be a little bit fancier, we could say how much more he needs. And then he needs approximately 5 feet more. And you can leave your answer like this. So you will get a point for having the correct trig functions, because this is a 4-point question. So you get a point here just for having those written out properly. Another point for having all of the correct proper work and showing conceptual understanding of the problem. A 3rd point if you add properly. And then your last point is just from answering the question and saying yes or no. When it says to justify your answer, you don't have to explain as long as your work is fully shown out, and you can still get that credit. Moving on to the next one, this is also a trig problem because we're given a right triangle and we know that we're solving for a side and we have an angle measure. So we're going to use SOHCAHTOA again at some point. And I think it's good to be able to notice what type of problems that you're looking at, because then you can easily identify if it's something that you're stronger at, something that you're weaker at, and also save you a little bit of time. So we have 16.5 as our reference angle, and as we said before, if we can create that straight arrow, that's always going to be our opposite side. If we can create that straight arrow from the right angle, that's always going to be our hypotenuse. And then the last side is not labeled for us, so we don't need the adjacent. So since we have sine and hypotenuse, we're going to use, opposite and hypotenuse, we're going to use sine. So we have sine of our reference angle, so sine of 16.5 equals 8, which is our opposite, over x, our hypotenuse. Same thing we did in the last problem, the same thing we're going to do here. Since x is in our denominator, we're going to multiply both sides by x. You only multiply by the denominator, so you don't get your work incorrect unless you're multiplying by the reciprocal. So now our new equation is x times sine of 16.5 equals 8. Since x still isn't by itself, we're going to divide both sides by sine of 16.5. So then these two cancel out, and we're left with x equals 8 over sine of 16.5. And all we have to do now is just plug that into the calculator. So 8 divided by sine 16.5. Enter, we get 28.167. Well, it's approximately 28.167. And we're rounding to the nearest tenth. So we want to find that value that's in the 10th place, which is that decimal place, or the place value that's to the right of the decimal place, so the 1. Then we're going to look next door at the 6. Since the 6 is greater than 5, our 1 is going to end up changing to a 2. So x is actually going to be approximately 28.2. And then we just drop those other numbers. So our correct answer here would be answer choice 4. For problem 3, once again, we have another trig problem because we're dealing with a right triangle, except in this case, we're given 2 side lengths, but we're solving for an angle measure. So we're solving for angle B. So first thing we want to do is draw a picture to match. So we're going to draw our right triangle, and it says it's ABC. The hypotenuse is AB. So if this is our right angle, we know the hypotenuse has to be the opposite side of it. So AB, and it has a length of 26 centimeters. The last letter we're missing is C, and then we know that the side of BC has a length of 17.6. So we're going to label this as 17.6 centimeters. And we need to find the measure of angle B. So we're going to label B as theta. Whenever we're solving for an angle measure, we still want to use SOHCAHTOA, but we're going to use the arc version of it. So for example, in this case, let's just label our sides first. So we have opposite of our 90-degree angle. So that's going to be our hypotenuse, meaning you're either going to be using sine or cosine. And then if you notice, we can't create a straight line here, which means that this won't be the adjacent. So since we have that, we know that we're going to be using cosine. But instead of regular cosine, we want to use the inverse. So we're going to use arc cosine. And in order to do arc cosine, it's going to be set up as cosine. So cos to the power of 1. And then we're just going to write our fraction. So our fraction is going to be the adjacent over the hypotenuse. Our adjacent side is 17.6 over 26. And then set that equal to theta. To put this into the calculator, we're going to have to do one extra step. So you're going to hit second and then cosine. From there, we just type in our fraction, which we said was 17.6 over 26. So 17.6 divided by 26, enter, and we get 47.39. And that's the approximate angle measure for theta. We're rounding to the nearest degree, which also just means the nearest whole number. So if you had $47.39, would that be closer to $47 or would that be closer to $48? This would be closer to 47, so we're going to choose 2. We can also just look at our 1's place value, then look next door. Since the 3 is less than 5, we know that the 7 is going to stay the same, so we are left with 47 degrees as the approximate value of theta. Next up, one of my favorites. It's a little bit more tedious. But in order to find the area of triangle BLU, we're given these set of axes, or these coordinates. You can use those, but I'm going to teach you guys the way that I teach my students so they have a little bit better of a visual. So we're going to turn this triangle into a rectangle in a sense. So we're going to add some area to it. But we're going to make sure that the area we add to it are running through each of these points of B, U, and L. Once we do that, the first step we want to do is find the area of the rectangle we created. So let's just count our sides. So we have 1, 2, 3, 4, 5, 6, 7. And then same thing below. 1, 2, 3, 4. So we know that the area of a rectangle